All right, this is AP A, B, and BC Calculus. We're doing Unit 8, Section 10, which is volume with the disk method again, but this time we're revolving around other axes, not just the X and Y axis. So let's go ahead and dive in. So the only difference in this video is that the axis of rotation, or AOR if we're abbreviating, is no longer the X or Y axis. We now need to pay a lot more attention to the way we find the radius. So recall from the 8-9 video that the radius for a vertical line, right, if we have an image where we're rotating this way and we have a radius that's vertical, right, to find the radius we do top Y value minus bottom Y value. If we have a disk that's rotating this way, to find the length of the radius, we do right X value minus left X value, right? That's what we're going to do. So the same thing here, it's just that the trick was when we were rotating around the X or Y axis, one of those two values was 0. And here, that's not going to be the case. So it makes it slightly trickier. We are going to lean a little bit more heavily on the calculator to do our actual integration in this video. It's the same skill set if you have to integrate by hand, but I don't want to spend our entire video doing tedious problems by hand. I want to make sure you understand the concept of how this works. So let's go ahead and get started. So here we have an interval, right? This shaded region, rather. We have an interval starting when x is -1 and going until x is 3. It's the region bounded by the curve y equals x squared and the line y equals -2. What we're going to be doing is we're going to be taking this region and we're going to rotate it about the line. Sorry, I scrolled down before you could see that. About the line y equals -2. So we're taking this region, right, and we're rotating it here. And again, that's not a good drawing and I kind of ran out of space, but this is my axis of rotation, okay? Axis of rotation is y equals -2. It's not the x-axis or the y-axis, right? So that's important because it's different from what we've been seeing, right? So when I rotate, I'm going to take a spot somewhere in the middle, doesn't matter where, I'm going to create one of my disks, right? So when I look at that disk, the radius is top y value minus bottom y value. So the hard part here is that I have to make sure my radius is the top y minus the bottom y. And that's fine, but here I'm used to having that bottom y be 0, and here it's not, right? The top y is the curve x squared. The bottom y is a -2. So my radius is going to end up being an x squared plus 2. That means that the area of this disk is pi r squared, which is going to be a pi times this thing, whole quantity squared. And so the volume is going to be from the first disk, which is at x is -1, to the last disk, which is at x is 3. So I'm going to integrate pi times the integral from -1 to 3 of this x squared plus 2 quantity squared with respect to x. And because I say that you're allowed to use your calculator to solve it, you can go ahead and type that in and get the answer, right? It is worth noting that if this was by hand, right, so if you were doing this by hand, what you would have to do is FOIL this out, right? So you'd have to FOIL this out, and then get x to the 4th plus 4x squared plus 4, and then you'd integrate the individual pieces. Okay, so that's if you were doing this by hand. I'm not saying that you have to do that by hand here. So if I were going to go ahead and do this in my calculator, I would hit second pi, right? And I would math 9, so math 9. I didn't put a function in, but I think this one's pretty straightforward, so I'm not going to. I'm just going to put, sorry, I missed a parentheses, x squared plus 2, close the parentheses, squared, comma, with respect to x from -1 to 3, right? So there we go. I hit enter. If I want to see what the number would be without the pi, I could take the pi off and then I could math frac it. So I'm going to get that this is approximately a 320.861. If you wanted to do it without the pi, right, you could hit second enter. Oh, my bad. Didn't mean to do that. I could hit second enter. And I could remove the pi. And then if I wanted to math frac, and this is a good way if you're checking an answer, right? I would get that, boy, I'm glad I didn't do this one by hand. This would be a 15232 rather, over 15 times a pi. Like if you were trying to find the exact answer, you could just do the part without pi and math frac it and get the answer. Again, totally okay to use your calculator on that. And we're going to do that in this video, although I'll make sure I mention how you would do it by hand. All right, so now we have P1, which is similar to E1. Again, you can totally just do this without me if you want. So we have the curve y equals 4x cubed. The lines y equals -4 and the line x equals 1. So this particular region is rotated about this line, y equals -4. So that's our axis of rotation. To create a solid. So it's going to look kind of, I know we shouldn't let me draw anything, but it's going to look kind of like this, right? So if we rotate a disk around, it's going this way. So my radius is going to be top curve, which is the 4x cubed, minus the bottom curve, which is the axis of rotation. So my radius is going to be top curve, right, which is 4x cubed, minus my axis of rotation, right, the bottom, which happens to be a negative 4. So I get that the radius is 4x cubed plus 4, right? That means the area of one disk is pi r squared, which would be pi 4x cubed plus 4 quantity squared. So the volume is going to be from the first disk, which is at x is negative 1, to the last, which is x is 1, so the integral from negative 1 to 1 of a pi times this thing squared with respect to x, and then type, and I get an answer. Now it is worth noting that if I were doing this by hand, I would absolutely factor that 4 out, because you could easily make this a 4 times an x cubed plus 1, and that's going to make your numbers a lot easier. So you'd end up getting a pi, a 4 squared, which is a 16, and this x cubed plus 1 times x cubed plus 1, which you could then FOIL and distribute, right? So if I were doing this by hand, I would yank both of these guys out of the integrand, and then I'd FOIL this out and then integrate, right? So I'm not actually going to do it by hand, but that would be a really useful way to keep your numbers a lot lower if you were doing it by hand. So instead, I'm going to go ahead and do second pi, right? So second pi, math 9. And here again, I have a pretty straightforward function, so I'm just going to go ahead and put it in as is. So that's a 4x to the third plus 4x. Oh, sorry, just plus 4, my bad. Quantity squared, right? So 4x cubed plus 4, quantity squared, comma, with respect to x, from negative 1 to 1. And enter. All right, and there we get a 114.892 or 3, depending on if you round or truncate. And as we've seen before, if you wanted to get the fractional answer, you could integrate just this part without the pi, get the answer, math frac it, and then put a pi at the end of it, and that would also totally be fine. All right, so let's go ahead and do this one. So the region bound by the curve, so this is the curvy part, right, the 3 minus y squared, and the line x equals 2 is rotated about the line x equals 2. So my axis of rotation is this line x equals 2. So basically what I'm going to do is get like this, oh, I'm terrible at drawing these things, but it's going to rotate this way, and I'm going to get a disk that looks like this. So my radius is going to be right minus left. So the radius is going to be the right x value, which in this case is the 3 minus y squared, minus the left y value, which in this case is a 2. Right? I would just leave it that way. You can clean it up if you want, but it's fine to leave it that way, right? So you could clean up if you want. You could make this a 1 minus y squared, or you could leave it like this. It doesn't matter. The area of that disk is going to be pi r squared, so that's going to be a pi. Again, totally fine if you want to leave it like this, quantity squared. Or you could put this in there. It doesn't matter. Really doesn't matter. Either or. So my volume is going to be the integral from the starting y, which is negative 1, to the ending y, which is 1, right? First disk to the last disk. Of a pi times this thing. You'll be surprised to find that if you look at an AP scoring guideline, they're literally going to have this curve minus this curve. They're not even going to bother to simplify it. And that's true if we go back one. I didn't have to simplify this. I could have left it as this if you wanted. It's absolutely fine. And then you're going to type and get your answer. So I'm going to go ahead and go second enter because I already did most of that work. Right? Oh, my bad. So instead of 4x cubed, I want a 3 minus, I'm going to use x squared, right, minus 2, right, and then that whole thing is squared, so 3 minus x squared, I used x instead of y, minus 2, quantity squared, with respect to x, and from negative 1 to 1, and that's our answer. It's got the pi and everything else, so we get a 3.351, right, and there's my answer. Again, if you wanted to do this by hand, you would probably simplify it to this, and then you'd have to FOIL out the 1 minus y squared times the 1 minus y squared. But if we're doing it on a calculator, we don't have to do that. All right, so here we have the curve 3 over y, which is this curve here, and also this curve down here, but we're only looking at this part, right? The line x equals 1, which is here, my bad, and the line y equals 1, which is here, right? We're going to revolve that around the line x equals 1. So this is my axis of rotation, right? So what's going to happen is I'm going to get this like kind of cone shape, but it's not really a cone, right? But sort of like a volcano shape, right? So this is my disk, right? That's my disk. So my radius is going to be, this radius is going to be the right x, which is totally 3 over y, right? Minus the left x, which is totally the x equals 1. So my radius is 3 over y minus 1. That means my area, which is pi r squared, is going to be a pi times the quantity 3 over y minus 1 squared. So my volume is going to be from the starting y, which is 1, to the ending y, which seems to be 3, right? I can see that that's true on the graph. So the integral from 1 to 3 of 3 over y minus 1 quantity squared with respect to y. And then I'm going to type and get an answer, right? So I'm going to go ahead and hit second enter, right? And instead of this function I have in here now, I'm going to make it a 3 over x, right? So 3 divided by x minus a 1, and then delete the extra spot. That looks right to me. And now I'm integrating from negative 1 to 3 this time. Oh, sorry, from regular 1 to 3, my bad. All right, so delete the negative to 3 and double check everything's cool. There we go. And I get that this is a 4.424, right? So again, if you were doing this by hand, it would be more complicated. You'd have to FOIL this thing out, right? If you were doing this by hand, you'd have to FOIL and then you'd integrate the individual pieces, and that's totally fine. But again, we don't necessarily have to do it by hand on every problem. The setup is what's going to matter the most. All right, so now we've reached the calculator required problem, so we're definitely going to be graphing these. So we have a region bound by a curve that we're totally going to graph, and a line that we're totally going to graph, and it's revolved around the line y equals negative 1 to create a solid. We're going to set up an integral expression for the volume and then use our calculator to find it. So the first thing we need to do is put these in our calculator, right? So I'm going to put this in as y1, and I'm going to put this one in as y2. Full disclosure, I've actually already done that. So there's my y1, 2x e to the 1.2x minus 0.75, and then my y is negative 1. So when I graph this in Zoom 6, this is definitely the tiny, tiny little interval I'm talking about. So I'm going to zoom in so I can see a little bit better. When you zoom in, you want to kind of scroll to where the spot that you want to look at, right? And then hit enter. And this is the region we're talking about. So once I know that, I need to find my bounds. So the first thing I have to do is I need to find my bounds, right? I'm going to have to find where f of x is equal to negative 1. So to do that, I'm going to second calc intersect, right? And I'm going to scroll to where I think that these hit each other. Close enough, right? Close. Enter, enter, enter. And I'm going to get that the first bound that I'm going to call A is approximately negative 2.4946662 dot, 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 dot. Second calc, oh, wait, sorry, quit out of that. And we want to store that as A, right? That's the mistake we frequently make if you're not paying attention. So alpha A, cool. And then go back to graph, second calc intersect. And then I'm going to hop on the line because the line will be the faster way to get to that spot. The line is a shorter distance than the curve. So I get to here, enter, enter, enter. And I get that the second one, the one I'm going to call B, is a negative 0.1495761 approximately, right? And I'm going to quit out of that. X, and then store that as alpha B, right? So I need those A's and B's. And so then what I want to do, right, once I know what this looks like, and you can kind of look at the graph, so here's my really crappy version of this graph. It doesn't have to be a great version of the graph. Here's my negative 1. I've got a graph that looks kind of like this, okay? So this is my, that was terrible, but you get the gist. Okay, so this is the interval I care about. And what's happening is this interval is getting revolved around this. So my radius is going to be top curve, right? My radius is going to be the top, which is going to be negative 1, minus the bottom, which is going to be f of x, right? So once I know that the radius is negative 1 minus f of x, then the area is pi negative 1 minus f of x quantity squared. So my volume is the pi times the integral from the thing I called A to the thing I called B, because that would be the first disk to the last disk, of this thing. Now, since the problem called it f of x, I can call it f of x. If the problem had said this was y, I would have to write out the entire equation, or the entire expression for f of x. But because they called it f of x, I can call it f of x. So this is the integrand you need to see, right? Like that's what the AP wants. They need these bounds, right? They need these bounds. They need this integrand, right? That integrand itself is probably worth 2 points. And then when we quit out of here, we're going to go ahead and hit pi, right? Math 9. And then I see that this is the thing I called y2, right? Minus the thing I called y1 quantity squared. So this this is for me only, right? This is not AP credit. This is something that I know I need personally. That's not getting me credit on the AP. So in parentheses, I go to vars, I go over to yvars function y2 minus vars over to yvars function y1, close the parentheses and square it, comma, with respect to x from alpha a to alpha b, right? And then I hit enter and I'll get my answer. So I get this is approximately a 0.440. So what the AP needs to see are you found the bounds, you used the correct integrand, you found the answer. That's what needs to happen. So let's go ahead and do another one right now. So again, full disclosure, I already put these in. I happen to use these as y3 and y4 because I was putting multiple things in my calculator. You don't have to do that, but that's what I did. I put them in my calculator as y3 and y4. So rather than retype it, I'm just going to turn off my y1 and y2. And you'll find that there are times that this is super useful. So if you have multiple curves or there's different problems in the same prompt, right, you might find it's useful to have multiple curves. So I'm going to go ahead and graph. Now here I don't see what I want, so I'm going to zoom 6 and see what I can see. So this is definitely the interval I'm talking about. And if you're trying to graph, like, again, you don't have to draw a bunch of stuff, but it can kind of help to draw a very basic form of this curve. This is basically what we're talking about, right? This interval right here is getting revolved like this. So the radius is definitely going to be the top curve, which is f of x, minus the bottom, which is 3. So f of x minus 3 is my radius. I'm going to need to integrate from the thing I'm going to call A to the thing I'm going to call B, which I will have to find. So I'm going to find A, I'm going to find B, right? But it's worth noting that even if you haven't found A and B yet, you could set up the integrand. Like you can figure out what this is supposed to be, right? It's R whole quantity squared. So my volume should be the integral from whatever A is to whatever B is of pi, right? And then my R squared. So f of x minus 3 quantity squared dx. Even if you didn't bother to find A and B, you can probably get here and get some of those points, right? And then I can get my approximate answer once I know A and B. So you can set up the integrand without knowing the values of A and B. Second, calc intersect, right? That's 5. I'm going to go to where the first one is. I always work left to right. It's not necessarily the smartest, but it's just how my brain rolls. All right, so I get this first one. I get that this is a negative 4.867257, and then don't forget to quit out and store that, right? So x store as alpha a, right? Go back to graph, second calc intersect. And again, it's faster to hop onto the line, so you can press down and get on the line if you want. It's a little bit faster. Enter, enter, enter. Cool. My second one is negative 0.1833824, right? I'm going to quit out of that and hit X and then store it as alpha B, right? And then honestly, you could go back up and just do second enter. I'm not going to here because I used y3 and y4. You probably didn't, but that's what I did. So I know that it's the thing I called y3 minus the thing I called y4. So I'm going to go vars over to yvars function y3 minus vars over to yvars function y4. Close the parentheses, square it, comma, with respect to x from alpha a to alpha b. Close the parentheses and hit enter. And I get that this is approximately an 8.060.